The fundamental structures. 5-unit structure. Input unit, arithmetic and logical unit, memory unit, output unit, and control unit. Input unit and memory unit transfer via direct memory access. Functioning. Data and programs are introduced inside the computer through the input unit. Input unit informs direct memory access about the presence of data and programs in the input unit. Direct memory access informs control unit about the presence of data and programs in the input unit. Control unit sends a command to the direct memory access to start the transfer of data and programs. Direct memory access forwards the command to the input unit. Input unit begins the transfer to the direct memory access. Direct memory access transfers data programs to the memory unit. Same happens for the memory unit and output unit transfer via direct memory access. Memory unit then informs control unit that the transfer in the memory unit has been completed. Control unit sends commands to the memory unit to forward the instruction to be executed. Memory unit transfers the instruction to the control unit. Control unit interprets the instructions, opcode and address commands in the memory unit that the operands localized at commands in the memory unit that the operands localized at the addresses specified in the body of the instructions to be transferred to ALU. ALU is the arithmetic logic unit. The arithmetic transfers to arithmetic logic unit. Memory unit transfers the operation to arithmetic logical unit. Control unit commands arithmetic logical unit to execute the operation specified in the opcode using the operands received from memory unit. The result of the operation is stored in algorithm logical unit. The result in algorithm logical unit may stay in there in order to be used for executing a new instruction, or be transferred and stored in memory unit. The result stored in memory unit can be displayed by the output unit by the means of direct memory access. The data results transfer from memory unit to output unit is performed the same manner as the input unit memory unit transfer. Input unit connects the computer and the outer environment, allows introducing information inside the computer. Two ways of functioning: direct, by means of input devices, keyboard, mouse, scanner, it's easier but slower speed, and indirect, by using intermediate medium in order to read information, card reader, microfilm reader, paper tape reader, etc. Process: human operator, document, intermediate medium, reader, computer. It's rapid but more time consuming to prepare information. Arithmetic Logic Unit, ALU, component of the Central Processing Unit, CPU. The only unit to generate new information. Carries out arithmetic and logic operations. It is high speed, the most performant and productive unit. Memory unit stores data and programs. Key characteristics: 1. Performance, access time, cycle time, transfer rates. 2. Physical type: semiconductor, magnetic, optical, magneto-optical. 3. Unit of transfer: word, byte, block. 4. Capacity: word size, number of words. 5. Location: internal, external. 6. Access mode: sequential, direct, random, associative. 7. Organization. 8. Physical characteristics: volatile, non-volatile, erasable, non-erasable. An optimal structure of memory would have the highest possible capacity and the lowest access time. Three basic functions: write, store, and read. Characteristics: capacity, volume of information that can be stored, bits, bytes, or words. Units: kilo, mega, giga, and tera. Access time is the interval between the instant when a command of reading is given and the instant when the data is available. Access time gives the speed of operation of the memory. Memory unit. The memory is organized as a hierarchical structure being layered in accordance to the capacity and speed. The major levels in the hierarchy are main memory, primary memory, internal, and secondary memory, that is external. These levels present sharp differences in technology, speed, capacity, management, and sub-levels. Internal memory, large volumes of capacity, high rates of accessing data. It has two levels: super operative memory, SOM, operative memory, OM. Super operative memory. The closest to the CPU, it has small capacity, very small access time, storing current instructions in execution, intermediate results, and the data involved in the current execution of the program. The main function, the matching of the speeds of operation of CPU and the operative memory. Expensive resource, aka cache memory. Control of operation for specific hardware mechanisms, transparent to the user. At present, CPUs incorporate a part of this memory. Operative memory, OM, contains the program in execution and the corresponding data. The capacity of OM is larger than that of SOM. The access time is worse. Nowadays, the OM capacity is measured in megabytes. Operation of OM is based in random access technique. Random access technique, the time to get access to any location is identical, regardless its address. Realized using semiconductor technologies, including RAM, DRAM, SRAM, memories. Secondary memory, external memory. Central unit equals the CPM and MM. SM, external storage devices, HDD, FDD, CD-ROM, DVD, ROM, etc. Greater capacity than MIMI. Greater access time than MIMI. Smaller cost per bit than MIMI. Stores large sets of data measured in megabytes, gigabytes, and terabytes. If a program is stored in SM, secondary memory, in order to be executed, it must be firstly be transferred to the MM. Transfer rate is rate at which the data can be transferred into or from a memory unit. Control unit, CU. It is computer's brain, role managing, monitoring, supervising the operation of all units from a digital computer. The CPU component ensures the complete automation of the computing process. Contains mainly registers, counters, frequency dividers, controllers, decoders, etc. Two classes, hardwired and microprogrammed. Control unit implements the fundamental mechanism of instruction execution. Reads the current instruction from the memory, decodes it, interprets it, in order to decide the function to be executed and to activate the corresponding control signals, and ultimately execute it, yielding the result. The output unit ensures communication between a digital computer and the outside world. Two main models of operation: direct, video monitors and printers; indirect, card punchers, tape punchers, etc. Input unit and output unit equals the input-output peripheral equipment, I/O units. Major I/O function: remote communication, enabling specialized I/O communication devices, modems, communication cards, bridges, routers, etc. Instruction cycle. Program stored in memory. Program set of instructions. Instructions are written in code machine language. Machine language instructions. Hence the program is called machine language program. According to von Neumann principle, the program is sequentially executed by the CPU, instruction by instruction. Definition: the set of operations to be performed in order to execute one instruction is called instruction cycle. Phases in executing an instruction: fetch, reading the instruction from the MU and transfer it to the CPU. Execute, executing the instructions and generating the result. The CPU must be informed about the operands, where the operands are stored, and where to store the result. The CPU must also know where to find the next instruction. Phases repeat while running a program. A sequence fetch execute is the instruction cycle, but the simple sequence of operations at infinitum. By this simple sequence of operations ad infinitum, a CPU can execute programs of any complexity. Phases fetch. The CPU reads from the memory unit at the address specified by the program counter. The instruction is to be executed and stores it in a register from the control unit called instruction register. IR. In CU, the instruction is divided into two major fields, opcode and address, and stored accordingly into the function register, FR, and address register, AR. CU decodes the opcode, i.e. the content of the function register, FR, decoding the opcode or interpreting the opcode. Execute. Phases. Using the information from the address register, AR, the control unit must determine the effective addresses of the operands. The CPU reads the memory again to extract the necessary operands. This phase is known to be fetch data. The operand is transferred in the algorithm logical unit. Sometimes operands are placed inside the CPU in the register file of the algorithm logical unit, constituting the local memory of the CPU. In such cases, a new read memory operations is not required. The data operands are much faster, supplied directly from the local memory unit of the CPU. The CPU effectively realizes the operation specified by the opcode by processing the operands according to the given operation of the instruction. Execute. The result can be stored in the memory. To realize this, a write cycle in the memory is started, by which the result of processing is stored in the memory at address determined at step 5. Most frequently, this step is missing from the instruction cycle, as the result is saved inside the CPU's register, for instance in a dedicated register, the accumulator, having a further processing accumulator. Accumulator. So, fetch instruction, store instruction in FR and AR, decode opcode, generate address of the next instruction. This is the fetch phase. Now, the execute phase. Calculate operands, addresses, fetch data, execute operation, and store the result. This is an instruction cycle. Some steps of the instruction cycle may be absent in certain instructions. No c'è stato di sì.
Why?
Non è stato importante. Always, the fetch phase is unique, whereas execute phase presents manifold aspects depending on the concrete instruction to be executed.